The James Webb Space Telescope has uncovered something truly remarkable: beams of light that appear to radiate from an urban center shining from a location 4 light-years away. This discovery has sparked renewed interest in the potential existence of extraterrestrial life. The telescope directed its focus towards Proxima Centauri b, the nearest exoplanet to our solar system, and noticed strange, brilliant flashes of light. Could these signals be signs of an alien civilization? Stay tuned for more developments. For years, both scientists and everyday people have been fascinated with the concept of life beyond Earth. Any evidence hinting at the presence of life in outer space has been met with great enthusiasm, but a pivotal moment came when the James Webb Space Telescope presented clear evidence suggesting the existence of life somewhere in the cosmos. While scanning the depths of space, this powerful telescope discovered something extraordinary. On an exoplanet located far away, it detected lights that resembled those from extraterrestrial cities, igniting the possibility that an alien metropolis might exist on that distant planet. This idea has generated significant excitement and curiosity within the scientific community, as it could be the breakthrough they have long anticipated. It hints at the presence of intelligent beings operating civilizations in ways we are only beginning to explore. Looking at these city-like lights from a remarkable distance of 4 light-years away, as we wait for our technology to progress to the point where we might discover them, NASA engineers are shocked and wonder how long they could have been visible in space. According to Columbia University astronomer David Kipping, the planet where these lights were found is especially complex. Unlike most rocky planets, which absorb sunlight and release energy as infrared radiation, this exoplanet behaves differently because of its special relationship with its host star Proxima Centauri. The James Webb Space Telescope's discovery highlights the importance of the telescope. Its capacity to record infrared wavelengths was critical in detecting Proxima Centauri b's peculiar activity, which is vital for comprehending the planet's atmosphere characteristics. The importance of the finding: in an effort to determine if this planet may support life, scientists want to keep using the telescope to examine its atmosphere in more detail. The James Webb Space Telescope is especially sensitive to infrared light, which allows it to observe events on Proxima Centauri b even at night. While many telescopes find it difficult to pick up even the smallest glimmers of light in the vast darkness of space, the Webb telescope is an excellent tool for confirming whether the purported city lights on Proxima b's dark side are real. The telescope can detect artificial light in space as long as it falls within a very specific frequency range that is significantly narrower than the light emitted by regular stars. Like many planets that orbit stars, Proxima Centauri b has a dynamic interaction with its star that greatly affects its environment. As the planet revolves around Proxima Centauri b, it experiences cycles of day and night, with hotter temperatures during the day and cooler temperatures at night. The wide range of temperatures on Proxima Centauri b is primarily due to its composition. For instance, if the planet lacked an atmosphere, the temperature difference between day and night would be extremely hot on one side and cold on the other. This dramatic thermal fluctuation is a key area of interest for astronomers because it offers important clues about Proxima Centauri b's atmospheric makeup. With its capacity to photograph in the infrared range, the James Webb Space Telescope can efficiently investigate the planet's thermal emissions, providing information on its atmospheric characteristics. The function of the Webb in future discoveries. Interestingly, Proxima Centauri b's orbital period and the James Webb Telescope's orbit around the Earth coincide, allowing scientists to observe its daylight cycles in detail every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step will be to examine its chemical makeup to see if it could support life. The James Webb Telescope is great for describing planetary atmospheres, and finding components like oxygen, water vapor, and methane would indicate the planet's capacity to support life. This would require analyzing the light traveling through the atmosphere, which is a complicated operation. It is mostly intended for other purposes. Although it is less skilled at detecting free oxygen, a vital sign of life, the telescope can still look for other important indicators like ozone, which indicates a healthy atmosphere, as scientists analyze the data collected from the James Webb Space Telescope. Its expertise lies in analyzing the concentrations of water vapor, carbon dioxide, and methane. In order to conduct more thorough studies of planetary atmospheres, Astronomers will need to rely on ground-based observatories such as the Extremely Large Telescope (ELT), which is scheduled to start operations in 2028. The ELT is intended to provide a deeper look at the atmospheric structures of far-off exoplanets, providing clearer and more detailed data on their potential to support life. The search for distant worlds is still ongoing, and it is getting us closer to the answer of whether we are alone in the universe. Similar to blocking the sun with your hand to see more clearly, researchers have big hopes for future space telescopes. They want to create technologies that lessen starlight interference so that people may see the planets surrounding them more clearly. The task is far from straightforward, though, as stars are extremely bright and frequently far outshine their surrounding planets. This brightness makes it difficult to detect the faint light that planets reflect, which is crucial for studying their characteristics. To address this challenge, scientists are developing a number of novel techniques. These future telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres and assess whether they might be capable of supporting life. One such technique is the employment of coronagraphs, which are instruments installed within telescopes that meticulously shape light waves to block off starlight while allowing light from the planet to flow through. By drastically lowering the star's brightness, coronagraphs may make it simpler to see the faint light from exoplanets. The Star Shade, a huge flower-shaped spacecraft that will carry information with a telescope tens of thousands of kilometers away, is another promising strategy. Starlight is blocked before it even reaches the telescope, allowing only light from exoplanets to reach the instruments. However, these cutting-edge technologies demand extraordinary precision, such as the alignment of a star shade over great distances that must be perfect to fractions of a millimeter. These innovations must also overcome the limitations posed by space missions, such as the need for miniaturization, energy efficiency, and the ability to withstand the harsh conditions of space. This technique could be especially effective in observing planets within the habitable zone of their stars where liquid water and possibly life could exist. Despite these challenges, there are a lot of potential benefits. If exoplanet atmospheres are successfully seen and analyzed, biosignatures, chemical markers of life, such as oxygen, methane, or water vapor in certain ratios, may be found. These molecules may indicate biological processes that indicate life exists beyond Earth. Researchers are also looking into ways to directly image distant worlds in greater detail. In addition to starlight blocking technologies, future telescopes may be outfitted with sophisticated adaptive optics that correct for distortions brought on by the Earth's atmosphere or the movements of the telescope, producing sharper images. These advancements could enable researchers to map the surfaces of exoplanets and investigate their climates in addition to detecting them. The creation of next-generation satellite telescopes marks a substantial advancement in our efforts to address one of the most important challenges facing mankind. By making it easier for us to see these far-off worlds, are we the only ones in the universe? Our understanding of our position in the universe may change as we come closer to discovering if life exists beyond Earth. As astronomers and scientists delve deeper into the secrets of far-off exoplanets, the future of space travel and the hunt for extraterrestrial life is developing at a never-before-seen rate. A new age of cosmic exploration is being ushered in by the James Webb Space Telescope. With each new piece of information, we get closer to the ultimate question: is there life beyond our planet's immediate vicinity? The data it collects is assisting astronomers in making groundbreaking discoveries about the composition, structure, and possible habitability of other planets. The finding of Centauri B, the star nearest to our own solar system, marks the start of what might be a significant paradigm shift in how we approach the study of alien life. Proxima Centauri has been a focus of intense research for years, however, until now finding concrete evidence of life such as artificial light or signs of civilization was a dream for many scientists. The fact that such light has been detected by the Webb telescope only enhances the hope that one day we may contact other intelligent life forms in the universe. This kind of discovery fuels both scientific curiosity and public imagination, inspiring new generations to think beyond the confines of Earth. As the James Webb Space Telescope continues its observations, it's not only looking for artificial lights but also focusing on planets' atmospheres, their chemical compositions, and how these factors could support life. The search for biosignatures like methane or carbon dioxide in the right concentrations is vital for understanding whether these planets have the right conditions for life. The Webb telescope has the ability to look at these atmospheric components in a way no other telescope has been able to, shedding light on the potential of distant worlds to support life similar to Earth. One of the most fascinating aspects of this entire endeavor is that we are observing history. The light from these planets takes years to reach us. As the data from the James Webb Space Telescope continues to roll in, humanity stands on the cusp of a new era, one in which questions that once seemed too far-fetched, like the existence of alien civilizations, might finally be answered. This means that what we are seeing now actually happened years ago, and every discovery is a glimpse into the past, a cosmic time machine showing us what once was.